Hi, my name is Elias Wooten, and I'm the ECE team lead. And today I'd like to go over some of the outcomes of our project. But first, let's cover what the project set out to do. The goal for this project is to have an automated growing machine for microgreens to have a fresh daily supply. In order to do this, we need a suite of sensors and actuators, as well as a user interface and a database. To illustrate our project, let's take a look at a full growth cycle of a tray of microgreens.
Starting a new growth cycle involves 3 steps. To start a new run, click on the chosen tray portal. At the bottom of the page is the navigation button to tray control. Select it. Select the desired microgreen from the list and click Start Growing. And then the new run will start and the device will take over all remaining actions.
Once you have selected the microgreen type, then you can spray down the seed mat, weigh the seeds, distribute them evenly across the whole grow mat, and place them in the device.
The Pi 4 switches 2 MOSFETs in order to turn on the 110-volt relays, which control the water pump and the air pump. These pumps, in conjunction with the Pi 0 switch solenoids, activate watering for all planted trays. The climate control keeps the growing environment between 24.5 and 28.5 degrees Celsius for optimal growth using a heater, fan, DC peristaltic pump, and TCE cooler. The heater is switched using a relay, and all other components are switched by NFETs. We also have 2 stepper motor circuits which work in conjunction with the pH sensor and the ECE sensor to keep the pH and nutrient levels steady inside our reserve water tank. To check to make sure all of these sensors and actuators are functioning properly, we just check the data stream of the scheduler function on the Pi 4's display in order to see live sensor data. After 2 days of germination, the lights will kick on and our microgreens will begin to grow rapidly. To test for a loss of power scenario, simply cut the power, return the power, and then in half an hour you can check the live data stream from the scheduler function.
Data collected by the device is displayed under each tray's portal. The graphs are created by feeding a dataset into the JavaScript library chart.js. The datasets for each graph are the measured values for each tray's sensors in the database. When loading the page, the device returns a query to the database for all the data for that tray from the start of the run to the current point in time or the end of the run, whichever comes first. Another part of the Atom Greens UI is the service page. The service page is used to trigger maintenance mode. Maintenance mode is the state of the device where all devices are temporarily turned off to allow for safe EC, pH, and water replacement. When you click the service page button, it updates a flag stored on the device database that is checked before it performs any actions. Once on the page, you can handle any of the alerts that will show up, you can run a set of diagnostics, or you can add a new microgreen profile.